everyone. Please, return your scantrons for quiz 4. And before I start the session, while you're doing that, I just make an announcement that you should be able to see student evaluations right now. And I ask you, all of you, to fill them out. And I will use your feedback for the course for the next semester. So if you saw something that you liked, for instance, if you liked having the textbook, if you liked having extra assignments, if you like things, just like say, so I can use your feedback. Also, if you didn't like something, you didn't like extra assignments, or you didn't like certain aspects of the course or the way I teach or anything, just like give me feedback, and I really appreciate it. And then when you have like the answers, kind of like strongly agree, strongly disagree, just pay attention. Sometimes you mean to choose like a strongly disagree, but by mistake you do, you choose strongly agree. So just be careful of that, because as I said, I really value your feedback, and it doesn't affect your grade. If you give me like bad review or like good review, I will see them after the semester is over, and it's anonymous. So I really ask you to fill them out. I know it just can be boring, or just like you have other things to do, but the deadline, is like, I think December 14th, if I'm not mistaken. So anytime that you have time, I gently, ask you, I just like really appreciate if you do that. And then when you have like 2 questions for like the course in general, but then it would be like evaluation based on the instructor. So just pay attention to that too, because you're going to evaluate me and Professor Estelle. So I really want you guys, to know which instructor you're evaluating, so I can, use your feedback, as I said. So any question about the student evaluations? Good? Okay, so I wrote your exam for last night. I started writing that before, but I finished that last night. So I thought, first of all, I gave your tutor the questions, and I asked her, and also the problem statements, the homework problems that I gave you previously, I asked her to solve those for you, the homework problems. And your exam is really similar to your homework problems. So if you did those, and then you know them, you understand those, you should be in really good shape for your exam. And to help you further, I also, before coming to the class, I went to the questions that I wrote, and I make notes of them, and I'm going to kind of review the chapter quickly and then solve the quiz for you. And before I forget, I just give you, try to solve all the quiz problems and tell you how to solve them, explain them. But I'm going to post the solutions to quiz 4 today, So even if I don't go through all the problems or not solve them till the end, you will be having all the solution procedures. So don't worry about that. And just focus on like what I'm saying, and then ask me any questions that you have. Is that clear? And I scheduled all the makeup exams this week because the materials in the previous chapters were really important for your exam 4. So I wanted you all to review those so you do well in your exam 4. But I had some students emailing me that there were some confusion about exams, or like they couldn't take makeup exams. So if you still feel the need and you want to take the makeup exams, just email me and I try to accommodate all of you. Any question about that? But as I said, I really wanted you to study chapters 1 to 6, because if you don't know those chapters, I think there is no way that you know chapter 7, 8, 9. Yes?
So will exam 4 be on chapter 7 and 9?
Yes.
Okay.
Yes. And then I'll teach you chapter 10 next week, and that would be on your final exam too. So your final exam is from chapter 1 to 10. And again, it's listed in professor schedule. It's like your final exam is like 10:14 a.m. till 12:14 a.m. No, sorry, 12:14 p.m. It doesn't take like that much of time, but 2 hours. So, and then you can see the location is the same, but the date is also not. This Friday is exam 4, not the next Friday, the Friday afterwards, but the exact, time, location, everything is in professor's schedule. Any more questions? Are we clear about everything? Okay. So, first of all, let me go through these slides. And as I said, if you know the answer to all these questions and you did all the homework, and again, I'm going to post these like I did for the previous session that I posted a PowerPoint. I'm going to post these as well, so you don't have to worry about writing them. Just, pay attention, and we can all do really well on exam 4. If you know these materials that I'm telling you today, you know how to do your quiz 4, and you know how to do the homework problems, I think there is no way that you cannot get an A in exam 4, honestly, unless you don't know these things. Anyway, so what is a combustion reaction? Can anyone tell me what is a combustion reaction? Yes? Say it. So one of your reactants reacts with oxygen and produce oxygen-containing species. So anything that you see, like CH4 plus O2 gives CO2 plus H2O. C plus O2 gives CO2. H2 plus O2 gives H2O. So if you have oxygen on the left side of the equation, so let me also write this. So you see one reactant plus O2 gives oxygen containing species, right? And then if you have, like in most cases, you see CO2 plus H2O. Usually you see water, but also C plus O2 gives CO2 is a combustion reaction. So as long as you see oxygen here and oxygen containing a species such as H2O, CO2, on right side you have combustion reaction. Any question about that? So I gave you a question, say which one of the following is not a combustion reaction? We should be able to identify that. If you see O2 here and oxygen containing a species on the right, is a combustion reaction. What is a gas evolution reaction? Can anyone tell me what was that? Exactly, you see a gas being produced. And I asked you, you had a table in your book that listed all the compounds that they go through gas evolution reaction, and we listed the gases. Any questions? Guys, I need all of your attentions. I have lots of materials to go through, and as much as I can go through these slides, more questions of exams you have. So please cooperate with me, have all your attention. And if you don't want to listen to the lecture, you can just go out and then just watch it later or don't watch it. I just need all of you guys' attention. Okay? So go to that table and you can see all the gas evolution reactions. And don't confuse that with combustion reactions. Because in combustion reactions, you can also see H2O gas plus CO2 gas, but that is not a gas evolution reaction because it's not in that table. Are we clear? What is an evidence of a chemical reaction? Can anyone tell me some of the evidences of chemical reactions? Yes? Yes?
Formation of bubbles.
Yes?
Gases emitted.
What's that?
Gas.
Yes, seeing a gas. And then the bubbles, be careful because they can also be physical change. If I boil water, I see bubbles, but this is physical change. So you should see new materials. Yes?
Formation of solid.
Exactly, like precipitation reactions, right? What else? Exactly, temperature change, like, and also, light emission or like heat emission or heat absorption, right? All of them are evidences of chemical.
So can change in enthalpy be evidence of chemical reaction?
Yes, exactly, because that is producing or absorbing heat. So physical versus chemical change. And then if, I asked you this in one of the homework problems, and then if you go to the book, you see more examples. And I asked from those. Some of them, if you open a can of soda, you see bubbles, right? Or you hear sound, right? So is that a chemical or physical reaction? Physical. Or like if we subliming a material, or like if we have evaporation, or like condensation, are they physical or chemical? Yes. Okay. So how do we balance the chemical equation? And what is balancing chemical equations? Why do we balance a chemical reaction? What law do we want to conserve? Exactly. So matter is not being generated or destroyed. We have if you have 2 moles of oxygen on the left, or let me paraphrase, if you have 2 oxygen atoms on the left side of the equation, you should have 2 oxygen atoms on the right side. And do you know when we balance a chemical equation, which element we do last? Exactly. If you see H2 by itself, or O2, or Fe, or Cu, or C by themselves, you just balance it last. So, can you tell me, I don't know the person next to you? So can you tell me, how do we write a complete ionic equation? So imagine I gave you an equation like NaCl plus Ki, right, gives the product. How do you write complete ionic equation? Do you know? Does anyone know? Exactly. So if you have NaCl plus Ki. So you say that, okay, this one is Na plus Cl minus K plus I minus. You write the ions, cations and anions, right? And then you see when you do that for the whole reaction, it's like the first homework problem that I told you, told you to email me the solution. You see some ions that they don't participate, so those are spectator ions. And you don't do this for liquid, solid, and gas. You only do that for aqueous solutions. And then when you omit spectator ions, you can write net ionic equation. Okay, so what is a redox reaction? Or oxidation reduction reactions? What is the definition? Exactly, but what is oxidation? Or how do we know what is the main characteristic of oxidation reactions? Yes, transfer of electrons, right? And then you should be able to identify them too. And then you had 3 main rules, so how to identify them? So I just encourage you to go to your book and then see, and then know the definition. I asked you true or false, Oxidation reduction reactions are reactions that they produce oxygen. True or false? False. It can be, but it's not the definition. We should have transfer of electrons. So solubility table. I asked you to remember solubility table, and I'm going back to this because I have the table to show you. But knowing that. And then greenhouse effect. What is it? What is the main greenhouse gas? Exactly. And then the definition I'm going to, ask you. What is it true or false? And I give you a definition. It can be true or false. So know that. And then stoichiometry. What is a stoichiometry? The relationship between the reactants and products, the quantitative relationship that makes you, solve the problems, right? It's kind of like your cooking recipe. So now, and as I said, the definition and how to balance chemical reactions. So is the following statement true or false? In chemical equation, we can change subscripts of elements. Exactly, because we don't change the elements, we just change the coefficients. Okay, now let me go to the solubility table. So I asked you to remember this table. To make your life easier for exam 4, as long as you know these ions here, you can answer your question in test. So compounds containing the following ions are mostly soluble, and these ones have no exceptions. So if you see a compound that has lithium, sodium, potassium, and this is group 1A, right? And then ammonium, nitrate, acetate. If you see a compound that has these ions, they are for sure soluble and they would be aqueous, right? So if I say like NaOH, KCl, LiBr, NH4, NO3, and so on and so forth. As long as they have like these, if you just remember lithium, sodium, potassium, ammonium, nitrate, acetate. So can you, I'm just referring to you two that you're talking till the rest of the class. So can you name these ions that I just mentioned? Yes.
Sorry, the ones you have written.
Yes, you just say.
Sodium hydroxide, calcium chloride, lithium.
Yes, it's just these ions here, these ones.
Lithium,
Uh-huh.
sodium, potassium,
Uh-huh.
ammonia,
Ammonium, yes. Nitrate, yes.
and I'm not sure this.
Acetate. So as long as you see these, and as I said, if you just pay attention now to me 100%, you can get an A in your test, and that is my main goal. So these ones, these, any compound that has these, they are soluble in water, so you see aqueous. Any questions so far about anything that I said? Okay, I already went through stoichiometry, so I go to the next slide. Okay, electromagnetic radiation. And we talked about this spectrum, right? But can anyone tell me the name of the electromagnetic radiation from the highest energy to lowest energy? What is the highest energy? Gamma, yes. What is the next one? Yes, what is the next one? UV, ultraviolet, yes. What is the next one? What is the next one? Infrared, right? And what was after infrared? And then? And remember, the most dangerous one has the most energy, gamma rays. And then X-rays, and remember the example that I said, that gamma rays are like the most dangerous one, just remember. X-rays, that's why the technician goes out of the room, because they don't want to be exposed to constant radiation. And then ultraviolet, you put sunscreen, because if you don't, and then you go to the beach every day, you get skin cancer, God forbid. But that is dangerous too, but not as much as the other two. And then ultraviolet, right after ultraviolet, you had violet, which is part of visible light. Did we mention visible light? Yeah. Okay, so visible light, sometimes I just try to go through the materials. I forget what I said. So we have visible light, and then the last light on visible light is red, and then you have infrared. So in that way you can remember that, right? And then you have microwave, and then you have radio waves. And then remember, gamma rays has the highest energy, so it's the most dangerous one. And energy and frequency, they have the same trend. The highest energy also has the highest frequency, but they are reversely connected with wavelength. So gamma ray that has highest energy has the smallest wavelength or shortest wavelength, And radio waves are kind of, as I said, it's kind of like has like long wavelengths, but the lowest, smallest energy. And I asked you from what I just said in the exam. So if you just learn this, you'll do that problems, 1 or 2. Any question about that? Good? Okay, so knowing that, wavelength and frequency, they have the same trend, but, frequency and energy, they have the same trend, and they are like inversely related to wavelength. The highest wavelength has lowest energy. Is that clear? Okay. What is Bohr model? Can anyone tell me what is Bohr model? I'm just gonna bring my book too. Meanwhile, yes, just say.
Electrons are placed in orbital near around nucleus.
So this is the thing that I tricked you in the exam. So you have like, in Bohr model, we don't talk about orbitals. We just have orbits. And it's kind of like the planetary description, that you have like planets, orbiting around the sun. It's the same thing. Remember, in Bohr model, you don't have orbital. So if I tell you which one of the following is the definition of Bohr model, and you see the word of orbital, it's not correct, because that is quantum mechanical model. In Bohr model, you have like a planetary description of electrons and nucleus. So you have your nucleus and electrons orbit around that. And you have like different orbits. And then you say like n equals 1, n equals 2, n equals 3, and so on and so forth. So in Bohr model, we only have n, principal quantum number, orbits. We don't have orbitals. Is that clear? So what was orbital, now that we are on the subject? So orbital, anyone? Yes, the probability of where electrons can be around the nucleus, right? And you all know what is probability, right? Yeah. Okay. So that is, remember, in Bohr model, you don't have orbitals, you have orbits. But in quantum mechanical model, you have orbitals to describe the probability of where electrons are. Okay, and now SPDF orbitals. Can anyone tell me what was the shape of S orbitals? What was P orbital? Exactly, and that's what I'm going to ask you in the exam. D and F, you can go to the book or like the slide that I posted, see the shapes, but just know how many electrons can be in each of them and how many. Can anyone tell me? So if I have these 1, 2, 3, 4, 5. Which one of these are S orbitals? Which one of them are P? Which one D? So here you can have maximum 2 electrons. How many here? How many here? Right? Because 1, 2, 3, and then I guess this is bad teaching. 1, 2, 3, 4, 5, and you remember that based on Hahn's rule, you fill them singly first and then pair them up, right? And same thing here. So electron configuration, including valence and core electrons and orbitals. So what was valence electrons? Exactly. So in the outermost layer, when you write the electronic configuration, you say 1s, 1s2, 2s2, 2p6, 3s2. Just for the configuration that I said, how many valence electrons do I have? So you go to the outermost layer, it means like the outermost n. So now I said 3s2. N equals 3 is the outermost layer. And number of electrons in that shell would be my valence electrons. So in this example, 3s2, 2 electrons are like my valence electrons. Is that clear? So for instance, if I have 1s2, 2s2, 2p6, how many valence electrons do I have? Remember, you go to the outermost layer or outermost shell. So here, n, and that is your n, remember. You can say n equals 2 is outermost shell. So in n equals 2, I have, total, this is 2s2, 1, 2, 3, 4, 5, 6. So in general, 2 plus 6, I have 8 electrons in n equal 2, right? So that is my valence electrons. Is that clear? Yes.
Is the n always determined by the coefficient?
Yes. So the outermost layer is the largest number of n's that you see. If you see like 4p6, is it the largest number that you see? That is your outermost shell, and that n equals 4 determines your valence electrons. But you should count that for all of the orbitals. So here you have 2 here, 2 here, and then you have s2, p6, and these are number of electrons. Do you remember that when we were writing those? So if I write like 1s2, 2s2, 2p6, you see the largest number 2, right? Any question about that? And then you go to all the orbitals that have the principal quantum number of 2, meaning like these guys here. And then you add these electrons. So you say 2 plus 6 equals 8 valence electrons. Is that clear? Any question about this? So if you have any questions about anything that I'm saying, just ask that, because I don't want you lose points because I couldn't teach something well. Okay? And now, anything that is left is your core electrons. So in this case, you have 2 core electrons. And if I ask you how many orbitals I have, you count these squares here. So here I have like 1s2, 2, right? So this is corresponding to my core electrons. So you count 1, 2, 3, 4, 5. So you have 5 orbitals overall. So just remember, as I said, when you see an electron configuration, you see the largest number that you have. Like here, you see the largest number is 2. You don't see anything more. And then you count all the electrons corresponding to 2 numbers. So you see like 2s2, 2p6. Those 2 and 6, the numbers that we write above are number of electrons. You have 8 valence electrons. You have 2 core electrons. Anything that is remaining. Good? Any questions? Oh, sorry.
How does that work when you get to 4s and 3d?
So again, you just look at the really good question. So you just look at the largest number. So 4d, that is 3s4d you asked, right? 4 is your largest number. So anything that has 4, those are your valence electrons. Does that make sense? So n equals 4, you count the numbers for those. Any more questions? Okay. Now, Pauli exclusion principle. Can anyone tell me what was Pauli exclusion principle? Exactly. Just what your friend said. So when you want to feel like orbitals, I'm just writing here, you can maximum have 2 with opposing spins. Clear? And what was Hund's rule? I just mentioned that briefly previously too. Yes, so when you want to fill out orbitals similar with the same energy, you fill them singly first, then pair them up. Clear? Okay. So now, let me go, it said Hans rule. Okay, theoretical yield, I always do that, okay. So, theoretical yield and limiting reactant. What is theoretical yield? Yes?
The amount of yield your equation says that you will have.
Yes, so the maximum amount of product that you can have based on your limiting reactant. And what is your limiting reactant? Or how do you determine limiting reactant? Limiting reactant is the reactant that limits your chemical reaction. It's kind of like the pancake example. Remember that I say like 2x plus 3 cups of flour gives 5 pancakes. And I have at home 2 eggs and like 100 cups of flour. I can only make pancakes based on 2 eggs. Although I have lots of flour, that doesn't mean anything. I cannot make pancakes with it because I don't have enough of one of the ingredients, right? So limiting reactant is the reactant that limits the chemical equation. And how do you find it? Can anyone know based on the quizzes that you did? How do you find limiting reactant?
Find the theoretical limit for compound.
Yes, you find the amount of product for each of the reactants depending on how much you have, and whichever gives you the smallest amount of product limits your reaction. So it's a limiting reactant. And I'm going to go, solve the problems for you quickly so you see what I mean, but know the definitions as well. What is enthalpy of reaction? Yes? Yes, the amount of heat absorbed or released in a chemical reaction that occurs in constant pressure, right? And I asked you, I'm just telling you, I asked you the definition of enthalpy and enthalpy of reaction. So go to your notes, to the book, whichever, to the lecture, and then, kind of like review enthalpy of reaction. And then periodic trends, atomic size, ionization energy, and metallic character. And I went through these really fast last time because I didn't have much time. So if you just remember, so these ones are these trends, and you saw that in the last homework assignments. I'm going to ask like 3 or 4 questions from these. So be prepared for that. So if you just look at your periodic table, can anyone tell me where do I see metals? Yes, so here, I just keep doing this. Okay, now I choose like the red. Okay, here you have alkaline earth metals. Here you have your transition metals. These are like inner transition metals, So here you see like most of the metals, right? And here you see most of the non-metals, and this one is actually non-metal too. Hydrogen is exception, but except that, in general. So if you remember this, and by now I hope that you know that, right? Your transition metal, you have transition metals, you have alkaline earth. So if I tell you that when I go from left to right in periodic table, metallic character increases, true or false? False. You see, and then if you just remember, and I give you the periodic table, but just remember, these guys, halogens, noble gases, they're not metal, right? And then, when we go from the above here, I cannot see it in my screen, so that's why it's kind of messed up. When you go from up to down, metallic character again increases. And you can remember that because here you have, and I have another image as well that shows that better, I guess. I can just demonstrate that as here. So here, you have like boron, silicon, germanium. Here you have your metalloids. Do you remember? So going from up to down is as if elements are transitioning from non-metal to becoming more metal. And then here you see metals. You see what I'm saying? What I'm going with this? Here, carbon is non-metal, and then you see metalloid, and then you see metals. So when you go, if I ask you, when I go in the periodic table from up to down, metallic character increases. True or false? True, right? And as I said, you can just remember these metalloids, that they are like between metals, non-metals. It's as if the elements are transitioning from being non-metal to metal. Is that clear? Any question about that? Because I just don't want you to just, memorize things without any rationale. Because if you just memorize a sentence without knowing what it means, you may forget it so quickly. But if you know exactly the trends in periodic table, things make more sense, right? Okay, the other thing was atomic size. Do you remember that I told you when we go from each layer, like n equals 1 to n equals 2 to 3, if I add one more n, number of n increases. So I will be having more shells. So having more shells means atomic size increases. And can anyone tell me what is the definition of atomic size?
Distance between the center of the nucleus and the outermost shell.
Exactly. So the distance between nucleus and the outermost shell is your atomic size. So if I have like n equals 3, the atoms would be larger, right? So is the following statement true or false? When I move up to down in periodic table, atomic size decreases. Is it clear for everyone why it is false? Any question about that? And then when going, I guess, I just show you this picture, not this one. Here. You see, when you go up to down, atomic size increases, and when you go left to right, you see atomic size decreases. And we said because you have like more electrons, the number of electrons increases, and there are like more attraction between valence electrons in outermost shell, and the atom. So the atom shrinks in a sense. It becomes smaller. Does that make sense? The number of n is the same, but more electrons. If we have less electrons, they have more freedom. So the atomic size increases if you have like less electrons. Any question about that? And last, we have ionization energy, which it was just a table that I showed here. So can anyone tell me what is the definition of ionization energy?
The amount of energy required to remove an electron from the outermost shell.
Exactly. So if again, the ionization energy is the amount of energy required to remove an electron from an atom. So do you think metals would be having higher ionization energy or lower? Right? Is that clear? Because in metals, you will be having cations, right? So if metals want to lose electrons, so there are like small amount of energy required to remove electrons. But halogens, for instance, you have Cl minus, Br minus, right? They want to gain electrons. So if you want to remove an electron from them, it's really difficult. So we should give that more and more energy because they want to not only lose the electrons, they want to attract. So they have higher ionization energy. Is that clear? Any question about that? So based on that rationale, when you move in periodic table from left to right, from metals to non-metals, ionization energy increases or decreases? What about up to down in a column? We remember that first we have more non-metallic character. Like if you look at like the groups 3, 4, 5A, you have more non-metallic character, and then you're transitioning to metals. So up to down, ionization energy increases or decreases? Because we're having more metallic character. Are these things clear? If everything that I just talked about is clear to you guys, you all are going to get 100. So now I have 10 minutes, and as I said, don't worry about the quiz. I'm just going to post the solutions today. So don't worry about that. But I'm just going to go through it briefly. I just wanted to make sure that I review these materials to you, because you should know these before going to the exam. And I have 10 more minutes, so don't rush me, guys. Okay, so insert. Go. Okay. So which of the following does not involve a chemical reaction? Which one? Okay, great. Is the following statement true or false? We are allowed to change coefficients and subscripts by balancing chemical equation. And read the whole statement in the exam. Now I'm just rushing to finish, so I just go briefly. Balance the following chemical equation by substituting A, B, C, D with suitable numbers. So which one of these? Okay, so yeah, that's the product of the apple, what it does. Anyway, so we have PbC2H3O22 Na2SO4 aqueous. I guess I just skip aqueous too. Gives PbSO4 plus NaC2H3O2. Remember, if you have polyatomic ions, and I just want to rush through, I just tend to yell. I don't mean to be mean. I guess you see that I just want to record and then just rushing through. Anyway, so polyatomic ions, when you want to balance them, don't separate them. Don't make your life difficult, right? So here, C2H3O2, C2H3O2, don't separate them, just balance them as themselves. And then the same thing with SO4. Don't separate them, don't make your life difficult. So if you don't do that, how many sodium should I put on right side? Well, what should be the coefficient? 2, right? And then you'll be having 2 Na here, 2 Na here. What about, so you have 1 Pb, you have 2 C2H3, 2 here, 1 here, 1 here. So the coefficients are 1, 1, 1, 2. 1, 1, 1. Is that clear? So don't separate polyatomic ions. Don't make your life difficult. Any question about that? Which of the following is not a gas evolution reaction? Is that clear? Why? Exactly. And if you go to the table that I just said, right, you see the reactions. Anything that is not that is this one. Okay. Which of the following compounds is insoluble in water? Which one? So this one is, so nitrate was among the ones that was always soluble, right? And then here, what about CAS? Okay, what about this one? B, what about this one? Soluble or insoluble? Okay, so this is the, but as I said, for your exam, these ones, you have your book, you can just look at it. For your exam on Friday, as long as you know which ions are always soluble. Can anyone tell me? Yes, lithium, sodium, potassium, ammonium, nitrate, acetate. Those are always soluble. Which of the following reactions is correct? So, see? So, again, you see Na, and you remember that to determine precipitation reactions, you write the ions, so you switch the anion, you switch the cations here. So here you have Ki NaCl, right? You have K plus I minus Na plus Cl minus. You switch the cations. and you write Na plus with I minus, K plus Cl minus. So you'll be having potentially NaI and KCl, but we don't know yet. But if you do, you'll be having this. You go to your solubility table. If they are soluble and aqueous, both of them, you won't be seeing any reactions. If you see a solid, you will be having precipitation reaction, right? Because in precipitation reaction, you mix two aqueous solutions and then you see a solid, right? So here, Na, K, they always are soluble, right? So they don't give precipitation reaction. And then the same thing here for like, it's kind of arrow, it becomes like this thing. So Na, nitrate, these are like always soluble. And then here, K, Na, they are always soluble, right? So these should be your answer. Is that clear? So when you want to see whether or not you have a precipitation reaction, you write your anions and cations for both of the compounds, okay? What I mean is that, for instance, for this one, Ki is K plus I minus, right? And from chapter 5, you know how to write this, right? You remember that your group 1 had the metals have charge of +1, these ones have +2, halogens have -1, oxygen, sulfur -2, nitrogen -3, right? So, and then for Pb, NO3 you have Pb2 plus NO3 minus, so, right? Is that clear? And what you do, you switch the cations. Is as if, it's double displacement reactions. And then you write a compound with Pb2 plus I minus and K plus NO3 minus. So this one would be Pb, or you don't even have to write it right now. You go to your solubility table, see what if these two ions combine. Is it soluble or insoluble? If you see they are. And then the same for like K plus NO3 minus is easy because both of these are soluble. So this one is soluble, aqueous. And then you see for this one, they are insoluble. So you see solid. So you have a precipitation reaction. Is that clear now? Okay, just email me if this is not clear or anything else that I'm saying. Which of the following statement is not correct? Compounds contain. So this is just like your solubility table. Go through the next question. So, which of these are not redox reactions? Why? What's that? So here you have like an acid plus base gives water plus an ionic compound or salt, right? For the other ones, you have like, transfer of electrons in all of them. Here you see just a metal by itself. Here you see like the transfer of electrons, or like again metal by itself. Here you see oxygen. So all of the other ones are acid-base reactions. Is that clear? So again, I went through what I did to make sure you do well on the test, but I'm going to post the solutions. But please, email me if you have any question, and I try to be available. I scheduled office hours for tomorrow. I posted in the website. I try to be at my office for most of the day. So if you have questions about any of these quiz problems, just come to me and talk to me. I just go through with them and review them with you, and hopefully you all can get an A in exam. That is my intention. Yes.
Like
Just have all of it. Yeah.
So I
that's fine. You have your name on it? Oh, okay, that's fine. Don't worry about it. Yeah.
Wait, so we don't need to put our solutions on the website too?
What's that?
We don't need to post our solutions on the website.
So I asked you guys to give me the Scantron here and post the solutions in BBLearn.
Okay.
Yeah.
That works.
Yes, exactly. I mean, not for the problems that are just like you know the answer or conceptual. I don't need work. You know what I mean? But for the solution, for things that need to write something, I just want.
I just put the Scantron on there, so is it okay if I?
Can you just email me that too, so I make sure that I have
Okay.
it? Yes.
So I accidentally turned in the wrong picture of, I turned in a picture of the Scantron, but I turned it in here too. On the back side, there's my work, so if you want a picture of the work, just like the mail to you.
So can I see that in the so?
No, so I only submitted the picture.
Okay, so
of the
just like
Scantron.
email me.
So can I just email you?
Okay.
Yeah, but
Yeah. Just do it ASAP because I'm just gonna post the solutions. Momentarily, of course. Okay, do you have them stapled those? Or like, do you have your name on it? Yeah. That's fine.
You still be good on the website.
Yes, so chapter 9, I still should finish it, but I finished for the first part of the chapter, so you guys have time to study that. I'm going to, so chapter 7, 8, and half of chapter 9 is on the website, but I'm going to post the rest tonight. Of course.
Well, if we sign up for a makeup exam, where would we go?
So did you see the email that I sent right after the sign-ups? So I already, proctor all the makeup exams.
Mm-hmm.
So if you just email me and I work with you to take the makeup exams. But I really wanted everyone to study them because if you don't know those materials, it's really
Right.
hard to do the rest. But just email me.
Okay.
Nice. Of course, it seems like there is no class after here, so I guess I have the class on. So what's up?
Just curious, I saw the email that you sent out that said that you can do all the extra credit before Friday. So will you still count?
Yes, of course. Yeah, just make sure to submit them. And I emphasize to submitting them because I asked like most of the questions in the test from the homework problems. So if you know how to do them well and just upload them, you'll find.
Thank you.
Of course.
We just about the quiz. So I uploaded my work and I accidentally missed like one page on there for my quiz. I'm not gonna get marked down.
Just email me that page that you missed.
Just a picture of it.
Yes.
Okay.
Just email me that.
Sweet.
Yeah.
Sounds good.
Of course.
Thank you.
So you want a digital copy of our work, or do you want us to turn it in as well?
If you just have it, I mean, I add.
Because this is where I did my work.
Can you just take a picture of it, upload it in BBLearn?
Okay.
Yeah. I mean, you can hand it here too, but it's just like more organized in BBLearn.
Okay.
Thank you.
So I didn't realize that there was a quiz for I was stopped on how to do a test yesterday and how to prepare for the one that the remake I'm doing today.
Okay.
So can I just post the answers online as soon as
So study the answers that they post because those are important for your exam, but I'm going to just email me. I'll write a makeup quiz for you. And it would be like next week, yeah. I mean, I have some students that they asked me for extensions and then they said they weren't doing well, so I'm going to write a makeup quiz for. So yeah.
Okay. So I just wait until next week?
Yes, I try to post it like this week or like, but just email me to remind me because I know who missed that. So,
Okay, thank you.
of course. What's
I'm
up,
sorry.
guys?
I just wanted to clarify. So McKenna, she already emailed you about wanting to take the retake exam.
Yes.
And I emailed too, and he said that I could sign up this week for it. And I did sign up, but I just wasn't sure where we were supposed to go for it.
Is it like your
Oh,
office
so you
hours or
already
something?
emailed me?
Yeah. And we
Okay.
already signed up and
I
stuff.
think it would be, so just come to my office, so it's like tomorrow at 4 and the day after, like tomorrow or today at 4.
Mm-hmm.
So I think it would be 2:20, but first come to my office and then we walk to 2:20. I think it should be fine, but I should make sure that the room is empty.
Okay. And then
So did I
I don't know, cause I emailed you about retaking the
okay,
exam
what
like
did I say?
before break, And he said to sign up, and so I just signed up for after break because I did want to. I've been studying over break for it.
So didn't I say to just
but-
show up to one of the times that I listed in the?
Yeah.
Okay, so that is my confusion because I said that in the times that I posted, I didn't post any makeup time for today and tomorrow because I wanted you guys to focus on exam 4.
Right.
But anyway, if you want, you can take it today at 4 or
Okay.
tomorrow at 4. But as I said, I just wanted to be considerate for you guys so you
Yeah.
have time for
Yeah.
exam
No,
4.
for sure. Yeah. And then can you remind me where your office is?
Yes, Renfrew 001.
Perfect. Thank you. Okay. So just show up there around 4 today
Yes.
tomorrow.
Yeah.
Okay. Perfect. Thank you so much.
Of course, of
Have a
course.
good
Just,
rest of your day.
you two just watch for the quiz solutions and then just email me if you have any questions about it.
Okay.